Alright, so the last type of factoring we're going to look at is a group called the special factoring. And what this involves is kind of special formats problems are written in that it can help you go straight to the factored solution. So the first type is difference of squares. This is the most common type of special factoring you'll run across. And what this says is if you have a square minus a square, this will always factor as two binomials where whatever you're squaring at the beginning, whatever you're squaring at the end, and one's going to be plus, one's going to be minus. It doesn't matter which parenthesis you want to write first, but you have to have one of each. They have to have different signs. So let's say I'm looking at 9x squared minus 16. Well, 9x squared is 3x being squared, and 16 is 4 being squared. So this fits that pattern, a square minus a square. So I'm going to have 3x minus 4 as one of my parentheses, and 3x plus 4 is one of my parentheses. And I would just write that as my if I was asked to factor this. So let's look at this. 50x cubed minus 98xy squared. Well, 50 is not a perfect square, so it doesn't fit this pattern yet. But I notice 50 and 98 are both even, so they both have a 2 that can be factored out of them. And x cubed and x, both of these have at least one x in common. So if I factor out a 2x, I get 25x squared minus 49y squared. And those are two squares. 5x quantity squared, 7y quantity squared. So this will factor as 5x minus 7y, 5x plus 7y. And then don't forget the 2x. So let's say I was factoring this. Now I could factor this the way it's written, but like I've said before, it's nicer if the x to the whatever power, the leading power term is in the front. And, even if I put that in the correct order, it's a negative. I don't like that to be negative, so it would be nicer if that was a positive. And so we can factor out a negative, and that would change the signs. That would make x to the fourth positive and 81 negative. As long as I keep that negative out there, basically a -1 multiplier. And then this is the difference of squares. X squared, if you square that, you get x to the fourth, and 81 is 9 squared. So x squared minus 9, x squared plus 9. Now, I can't stop here because x squared minus 9 is still the difference of squares. X squared is a square, 9 is a square, 3 squared. So I could break that part down into x minus 3, x plus 3. But notice the x squared plus 9 does not break down. It is a sum of squares, and this says that you have to be subtracting squares. So within the real numbers, that part will not break down. So it stays x squared plus 9. We should always try to get down to a power of 1 for our variables, but sometimes you can't do it, and in this case, as an example, you can't do it. Don't forget that negative at the front. Alright, so the second type of special factoring is a perfect square trinomial. And what this says is if you have something that looks like this, it has to be a trinomial, both ends are perfect squares, and the back end has to be adding, then if the middle is whatever I'm squaring on the front times whatever I'm squaring on the back times 2, that's this perfect square trinomial format. And you'll notice that little plus, and it looks like an underline, that's actually plus or minus. What this is saying is that middle term could be a positive or it could be a negative. And if it's a negative, then when you factor this, what we're going to get is what are we squaring on this end, what are we going to square on this end. If it's a plus in the middle, we're adding the second thing. If it's a minus in the middle, we're subtracting the second thing. What this is saying is those two parentheses are identical. And so, you have an a plus b times another a plus b, or you have an a minus b times another a minus b. So that's what a square means, is you're duplicating the exact same thing. So let's say I wanted to factor this. I would look at this and I would say, okay, does it fit this pattern? Well, yes, the front is I have three things. It's a trinomial. The front is a perfect square, 2x quantity squared. The back is a perfect square, 3 being squared, and it's adding. So the question is the middle fit that pattern? So the front is 2x, the back is 3. Is the middle 2x times 3 times 2? And the answer is, well, 6 times 2 is 12. So yes, it does fit that pattern. This is 2x plus 3. Again, that's plus because the middle is plus 3 quantity squared. So I wanted to factor this. So the easiest thing, instead of trying to determine if the middle works before you try it, is just go ahead and take a shot. Say, I think it is probably one of these, and let's see, 9x squared in the front means the front is 3x. Positive 25 on the back means the back is 5. The sign in the middle is negative, so the middle sign needs to be negative. So then it's just a question of, does the 30 actually stand up to this pattern? And so what you're looking at is, does 3 times 5, so 3 times 5 is 15, times 2, does that equal 30? And the answer is yes. So this is the correct way for it to factor. Let's look at this problem. 18x squared y plus 84xy squared plus 98y cubed. This does not fit that pattern. 18 is not a perfect square. But if I look at these, I should always look for a GCF. And I notice everybody's even, so everybody's a multiple of 2. Everybody has at least one y, so I can factor a 2y out. And then I get something that fits that pattern. I got 3 terms. The front, 9x squared is a perfect square. 49y squared is a perfect square. So I'm going to take a shot and say, this probably is a perfect square trinomial. Let's see. 3x is what I'm squaring on the front. 7y is what I'm squaring on the back. So the question is, does the middle check? Does 42xy verify this as a perfect square trinomial? Well, what's 3 times 7? 21 times 2 is 42. So this does fit that pattern. 42xy is what you get when you take 3x times 7y times 2. So this does fit a perfect square trinomial. It should be noted sometimes people don't catch the perfect square trinomial and they end up factoring this as the product of binomials. And that's okay. It's just, if you recognize it, like if you can look at like the first couple problems I did, you can see how quickly they can be done. But if you don't catch it, that's okay. You'll catch it as a product of binomials. Take 9 times 49 and work it out that way. All right, so let's say I wanted to factor this. And I say, okay, I got 3 terms. 9x squared is a perfect square. 16 is a perfect square. So I think this is going to be 3x, the middle sign minus. So 3x minus 4 quantity squared. And I say, does that work? Well, 3 times 4 is 12. 12 times 2 is 24, not 26. So it doesn't work. That's okay. Just notice how much time we spent on it, a couple seconds, to just check it to see if it worked. And if it worked, great, we're done. It doesn't work, okay, well, I guess I'll do this the longer way. 9 times 16. What are those factors of 144 whose sum is 26? This is how we did the second part of the product of binomials when that first term is not a 1. And so we go through all those factors and we start looking at which ones add up to be 26. So 1 and 44, no, that's too big. 2 and 72, 74, way too big. 51, that's 40. 30, we're getting closer. 8 and 18 is 26, so no, 9, no, okay. So again, those middle terms, the reason why we're finding their sum is because they both have the same sign, and they're both, in this case, if we look at the middle sign, they both have to be negative. So we're going to write that out as 9x squared minus 8x minus 18x plus 16, and group those up. First two have in common x, so get x, 9x minus 8. Got to get a 9x minus 8 on the second part, so that means we had to have factored out a negative 2. And again, just take negative 18x divided by 9x, and that'll tell you what that thing has to be. And then don't forget to finish this x minus 2 times 9x minus 8. So, this is more of this example, you might be going, why are we talking about this? Because we just did a review of what the last video was about. But my point was, notice how I tried to do the perfect square trinomial at the beginning. And it didn't work. But it could. And so in cases when it does work, I'm saving myself the rest of this work that I just did. I could do any perfect square trinomial the way I just did. But I wouldn't want to do that if I could do it quickly. So if you notice you have, some of the features of a perfect square trinomial, you should probably just, 3 terms, both ends are perfect squares, the back end's adding. You should try it. And then double check the middle. And if it doesn't work, then you'll do it this long way to do it. That's okay. All right. The last type of special factoring, and some courses won't cover this, is the sum and difference of cubes. And sum and difference of cubes, if you have a cube plus a cube or a cube minus a cube, the pattern is, pretty much the same pattern. So what you get is a binomial, and what am I cubing? What am I cubing? And if it's a plus in the middle, this binomial has a plus. And if it's a minus in the middle, this binomial has a minus. And then I get a trinomial term in each of these cases. And that trinomial is, it's easiest to think of how this trinomial works if you look at the binomial you initially built, the a plus b. So this trinomial is the a squared on one end, the b squared on the other. And notice, if you look at way back at the beginning of this expression, a cubed plus b cubed, there's no a squares, there's no a's, there's no b squares, there's no b's. And it's because all those terms canceled out. And so what you have in this trinomial part is the a and b as big as they are together, but the opposite sign, so that they cancel all those out. Now don't confuse this with a perfect square trinomial. That's a whole nother issue. But this is the same for if this is a minus b. One end's a squared, the other end's b squared. In the middle, it's a times negative b, but the opposite sign, so positive ab in the middle. So you notice the first binomial part always has the same sign you started with. And then in the trinomial, the middle part is always the opposite of what that sign was in the binomial. And if you kind of keep that straight, it'll make factoring these a lot easier. So let's say I have 8x cubed plus 27y cubed. So this helps if you know what your perfect cubes are. 2 cubed is 8, 3 cubed is 27. So this is going to be 2x plus 3y. Again, what am I cubing? What am I cubing? Same sign. I'm adding, so I'm adding. And then my trinomial, I'm going to square 2x. That's going to give me 4x squared. I'm going to square 3y, so that's going to give me 9y squared. And in the middle, it's 2x times 3y, opposite sign. So 6xy, but it's going to be a negative 6xy, so that it'll cancel out all those middle terms. If I have y to the 6 minus 125, again, 125 is 5 to the third power, 5 cubed. Y to the 6 is a y squared times a y squared times a y squared, so y squared being cubed. So this first binomial expression, y squared minus 5, and again, square the y squared, that gives you y to the 4th, square the negative 5, that gives you positive 25. In the middle, it's y squared times negative 5, opposite sign, so positive 5y squared. Alright, so now that we've talked about all the different techniques of factoring that you're likely to see in an algebra course, then you might be wondering what order things should happen in. And so what you should first look for is the greatest common factor, always. Sometimes problems don't really make much sense, and then you take out the greatest common factor and suddenly it fits some other type of factoring scheme. So always look for that greatest common factor. It's usually the easiest thing for people to find, but they oftentimes forget to look for it, and they run into trouble. Next thing you should look for is to see if you can do grouping. So if you have like 4 terms, you can do grouping, or maybe you have 6 terms and you can pair them up in sets of 3 or 3 sets of 2 or something. Always try to do grouping. If you have 4 terms, you can't just get rid of one of the terms and try to do it some other way. You know, if you have 4 terms, you're going to have to work with all of those. So look for grouping. After you've tried those, see if you can do any of the special factoring. And you should approach these in this order. You should first look to see if you have the difference of squares. So if you have 2 terms, you're subtracting and they're both squares, then you should factor it that way. If you have 3 terms, you should look to see if it's a perfect square trinomial, where both ends are perfect squares. That last one is adding, and then try it and then check the middle and see if it works. And then in other cases, sum and difference of cubes. If you have a cube minus a cube or a cube plus a cube, then try it in that technique. Now, if you've tried all of that and you still have an expression you're trying to factor, you should look to see if it can factor into the product of binomials. Now, this is the last thing you should approach doing. Ironically, this is also the one you will probably do most often. So, because this happens most often, this is the ones we usually see in algebra courses, then a lot of times students will just immediately try to go straight to this and won't check for a GCF and won't check to see if they can do grouping or one of these special ones, and they run into trouble. And so you should always approach it in this order. Look for the GCF, look to see if you can do grouping, see if it's one of those special ones, and then if none of that works, then do the product of binomials. Or you've already done it and you still have something left over that still needs to be factored, then do the product of binomials.